привет.
Good morning, everyone. I'm Ilya Kosinkin. I'm a product manager of one of our products, and today I'll talk about our experience of development of information security expertise for industrial control systems, or ICS, in positive technologies. And I'll talk about this as an applied project that we have been doing for a while. We'll talk about security experts and coders. In the first section, we'll talk about what security expertise there is for products, and we'll talk about, in our second module, the various DSLs for the expertise that we use in our products, PTESIM. And DSL are domain-specific language. I'll talk about examples of such languages, how we use them, and what features they have. And finally, in section 3, we'll talk about processes in development, the people, the roles, and why it's not as simple as it might seem at first glance. Let's start with section 1, information security expertise in products. When we talk about products in security, cybersecurity, there's a lot of those. If you look at what solutions are available, you would be surprised at how many they are. But they solve two main objectives. First is intrusion prevention. When you are being attacked and your objective is to prevent that attack. And second is security control. That is almost an opposite task. We're not being attacked yet, but we want to build our fortress as strong so that no one could ever attack us. Okay, intrusion prevention. What are the goals of such products? First is detection. The main thing that we need to do is to answer our cybersecurity guys if there is an adversary in our infrastructure. That is the main objective. And if we were to look into it in more detail, it would be what hosts, what accounts the adversary has access to. And the second important process is response. When we see that the adversary is in the network, we need to stop them. And it's important that the response does not turn into a situation when, by stopping the adversary, you crash the process and created a bigger problem. I wanted to draw an architecture here, but I decided not to do it. So let's just look at the main flow of events and see where cybersecurity expertise comes into play. To detect an adversary, we need to understand what's happening in the infrastructure. The data source typology, there are two of those. There are data logs. If you write logs, they are not only read by humans, they are read by machines as well. So you want to make them machine readable. Okay, so those are logs of operating systems and codes. And the second is network traffic. By analyzing the traffic and the logs, we can understand what's happening in the infrastructure. And as outputs, we get entities such as events. And these are quite numerous because infrastructures are big and a lot is happening. And so for cybersecurity experts to bring it to their attention in terms of the highest alerts, we have these security events. There are rules that analyze if there are any traces of adversarial activity in the events. And that is the end of the intrusion prevention story. If there's an event, we alert our cybersecurity. But in practice, such products generate quite a big number of alerts. So that is why the most recent next-gen products, they have made a step towards chains of events. Responding to where cybersecurity expertise is, it's marked in yellow here, and it is present almost at every step. When we gather source data, we need to understand where to gather it from, what logs we need, and this is where cybersecurity expertise is very important. Not all data that exists in the infrastructure is of interest for us when we don't want to overload with useless events. Second, the expertise in intrusion detection. That is perhaps the clearest expertise. Okay, so we see events, a list of events, and we want to understand where there's an adversary and where there isn't. And finally, the expertise of analyzing those entities and seeing that there's a chain between them or among them. And then there's response. Response is either manual or automatic. There are systems of alerts and chains of incidents. In terms of chains of incidents, you have a better knowledge that an attack has happened, and you can respond with a lower risk of causing more harm. Let's look at the second class of products, and these are security control products. And there are, again, two main questions. First, we need to assess the current level of security of our infrastructure to see what hosts we have, what routes exist between those hosts, what accounts are there, what vulnerabilities are at the hosts, on the hosts. And secondly, process design. So how quickly we address the critical vulnerabilities. Have we not violated any processes or procedures? Okay, and so the structure of such products. First, we need to understand what we want to protect, we want to understand what software exists on which machines, what hosts are there. And systems approach that by active scanning of infrastructure. They gather information from network devices in terms of routes, check active IPs, connect to machines and inspect software, and we get an asset database. And so the first point of expertise is what data we want to collect, what would be useful. How do we collect data in a secure way? Imagine you connect to a high-load server and start inspecting it, and the server crashed. This shouldn't happen. So an important expert's task is how to gather information by reducing the workload on the equipment. Once we get our asset database, we know what the protected infrastructure is. We want to analyze it for vulnerabilities. And vulnerabilities are essentially loopholes in security when you can get remote access to a working service and execute a code without having any accounts in the host machine. So there is a database of vulnerabilities and patches released by software developers, and you want to match this database with the outputs of scanning. And finally, an analysis of weaknesses in configuration, such as, for example, you can have a weak password and it can easily be reproduced by the adversaries. And you can see the numbers here. If we take 10,000 nodes on any Windows machine, if you scan it with a modern scanner, you would see 1 to 1.5 thousand vulnerabilities on an average modern Windows machine. If we multiply that by number of machines, we get a few million. The point is that it's very difficult to deal with all of this. If you look at screenshots of typical cybersecurity products, vendors would brag that they would provide dashboards with millions of vulnerabilities, but that is not very usable. So the modern software tries to make a next step and to analyze those vulnerabilities and to prioritize them. It's implemented differently in different products, but the important thing is that the attention of cybersecurity specialists is focused on potentially more high-priority vulnerabilities, and this is perhaps the less standardized aspect of such products. And often there are things such as trending vulnerabilities. We can see what are the most common vulnerabilities, and there would be not so many of those, and those would have to be addressed as a first priority. Then various vulnerability prioritization policies, including in terms of simplicity, such as you install a patch and you cover thousands of vulnerabilities. Various other sortings and prioritization. And perhaps the most next-gen approach is analytics on the possibility to exploit the vulnerabilities with account to the paths of attack. There are many cybersecurity products, but you can see that even in quite not so numerous tasks, you can have many products. Products are developed by coders. When I first started to work as a coder many years ago, I thought that a coder is the only person that would create codes, but that is not so. Talking about developers, the main competences that we imply are the ability to write code in a professional way, and if a developer evolves, they would often evolve to more high-load applications, to more sophisticated architectures. And if you take an interview for a developer, even in a company that deals in cybersecurity, you would get questions about how well you know the target platform, the solid garbage collector. I'm confident you're tired of questions like this. So among those competences, there are none that relate to cybersecurity. If someone asks you how many vulnerabilities of Windows you know by heart, and if you get asked such a question, then maybe the purpose would be to understand if you can write secure code. So if you want to translate this knowledge into the products that we talk about, you need competent people, and let's call them cybersecurity experts. What competences are important for them? They've got to understand how target systems function, the systems that we are there to protect. Secondly, they've got to know which methods of attacks are there, and they want to follow the new approaches in attacks, and they emerge very fast, sometimes within a matter of days. And finally, such an expert must have certain soft skills, such as the unquenchable desire to put all this knowledge into practice. So how do we bring together the experts and the IT guys? There are two ways, both of them work, and let's start with the one which is labeled here as the most seldom. If the cybersecurity person does terms of reference, and the coder implements these terms of reference. This is very similar to the operation between a systems analyst and the developer. But in cybersecurity, the more widespread is a little bit different approach. That's when experts get some specialized DSLs. Those are languages in which they can develop their expertise, and the objective of the developer to write an engine that would execute this DSL. That would be the segregation of duties. What are the benefits of a DSL? There must be more, but let me highlight just three, the most important ones. First is the speed of development on the expert side. Experts are not magicians, and as developers, they cannot write code in one iteration. So it's not always possible to just sit down and explain how it should work right from the first time. So there should be an opportunity for them to test their hypothesis, to debug and adapt the work to their needs. And second is more on the product side. It's important that cybersecurity guys must have tools to deliver their expertise quickly, and it would be good if you wouldn't have to update binary models. DSLs are text files. You can bring them to installation without changing much. And the third aspect is more on the product side. Partners often get an opportunity to write their own rules and share their expertise without going into too much coding. Okay, those were the three areas. And let me talk about DSL for IB expertise that we use in our product PT-ISIM. And let me first explain how the product works. What's the structure of it? The goal of the project is to detect attacks in the network traffic of ICSs or industrial control systems. So we get a copy of the traffic, analyze it, and try to understand where there are traces of an adversary there. How we do that? The network traffic is analyzed by several DPI modules, the objective of which is to convert the binary flow into an event flow that would be analyzed. And the DPI modules use a proprietary language that is called Cognac. We'll talk about it. And there's also the standard language called Suricata rules. Once we have identified events, we start looking at a number of tasks. First is building a typology. That is just a feature of the product where we explain which nodes are active and what protocols they use to talk to each other. To build the network topology, there's a language for that, and it's called MIL. Second is attack analysis, and it's developed, or it's done based on a special product which is called a correlator. And during the next presentation, the speakers will talk about what it is. Okay, so we have looked at our events, and we give them to the operator for analysis. And chains of incidents is what we also have. And we do that without any DSLs, with hard coding algorithms. Okay, let's start with the first language, and it's called Cognac. The main objective of it is to detect events in the traffic. And the features are first the declarative description of data structures. But at the same time, there is a possibility of imperative processing of data. And because we're analyzing network protocols, and you know that network protocols are nested into each other like an onion, there are tools to analyze nested protocols. And finally, a temporary data storage. You would also know that in network communications are sort of call and response time. And sometimes you want to use the data from the call into the response. How you do that? The best way is to use this temporary data storage. You put the data there and you use it at a later stage. I think you don't see this small, you can't see the small prints, so let's look at this in larger print. This is a sample code, a hypothetical example. This is an analysis of a synthetic protocol, which is called the Dream protocol. Okay, so first, we declare a section which is called a Dream Protocol Frame. This section describes how we count messages. We go to number 2, and you can see that the first fields are the source fields, which have to be read as uint8 and to be converted into an internal data type, which is a MAC address. Events have a typization, and a MAC address is one of such typization attributes. Then there is a type field. And so we read certain fields, and that could be it. But life is more sophisticated than this. So if we have this 600 type of message, then we need to analyze the structure of the message. And we follow this number 3 arrow. We use this sequence function, and you can see that it has the field type. Depending on the type, we use various fields. Exciting. I believe quite exciting. And there's another nice structure. So if the type is error, we read the error code. But the error codes we want to convert from numbers into strings. And there's a map structure, which is an elegant way to do that. So that was an overview of the structure on section 5, by the way. After we've analyzed the mainframe, the purpose is to send this to the next analyzers. which are next down in the onion, so to say, and we create certain event codes which send the further processing to one or another subsequent processor. Let me highlight the advantages of this approach here. When we talk about DSLs, there's always a specific task, and for that there's a specific programming language. And I believe that Cognac fits this definition very well. See, the objective is to analyze the binary flow, and there's a specialized solution, and we can do a declarative approach, and if the declarative approach is not enough, we can write imperative structures. This is a simple one. There can be more sophisticated ones that can help us achieve the stated objective. I don't know how you feel about it, but I believe that this is a true DSL language, an exemplary DSL language. And let's talk about another language. And it doesn't have a name as far as I know. It's a language of the correlators. Stanislav will talk more about it in the next presentation. I'll just highlight a few features of it. It's quite widely used to write the rules for an attack detection. And it's used in CM. Partners use it to write, to code their expertise. And there are two patterns of writing rules in this language. The first pattern is when we want to detect a single event and make an incident out of it, such as we know, for example, that a malicious process is being run. We know its name. We look at the name, search for this name in the events if there's a match, and we then make an event out of it. But often, one event is not enough to identify that something malicious is going on. And the correlator helps build chains of events. Let me give you an example of a chain of events. First is an example of brute force. So we, in block 1, we look for events. And in block 2, we analyze the chain of events. If there's more than 5 of these in 10 minutes, then we see that someone is trying to brute force the passwords. But the correlator has a very flexible syntax for describing such chains, which offers endless combinatory opportunities. And imagine you want to check for device scanning. Some host suddenly starts sending lots of packages through the network, and they must be looking for whether there are any open ports. Or a host starts sending lots of packages to different ports, trying to see which ports are open, which ports are occupied by which services, etc. And this is this final block, which is called use difference. You take network packages that have the same source and the same destination. And you can solve the problem that I've just described to you for almost a minute in a one string. So this is a cool DSL that can identify strings, and it has very good filters to detect events. And I guess this also fits well the definition of a DSL. There's a specific objective and there's a language to address it. The next language that we have is MEAL. That is a language to build a network map. This is a more imperative language, but if you came across such approaches in development as DDD, you would know that the idea there is to isolate a certain logic layer, isolating it from buses and other entities to get a layer which describes the business logic. And MEAL helps write such business logic. This must be too small to read, but we'll look in more detail at next slide. So the objective is to analyze the topology of the network, describing the model, so to say, of the world of that network. And it's important to fill those entities with events. the events we've got at the first phase, and then we have to match those events to those entities. Not all tasks require an event. Sometimes you just need a timer, and timers are also covered. This language has an opportunity to create incidents. So this is an useful language to map network topology. And let's look at more real-life example. We gather traffic from the target network, and we want to see what hosts are in the infrastructure, and for a number of hosts to identify incidents. First, when the new host appears, when the traffic disappeared from the network from that host, and when it reappeared. Okay, let's look at how we can address that. Let's look at arrow number 1, where we declare the necessary data structures, the host here, and a few events that we found in new host, that the host has become active or the host has become inactive. Okay, so we have modeled the target network. Then in number 2, we say that we want to store our hosts, and there's a timer set up in section 3 to do periodic checks. The business logic is implemented into processors. One number 4, the other number 7. So in the first one, we process all incoming network events. In the other one, we process timer events. And here's what we do. So this just describes business logic. When there's an event, we search the host with the target IP in the list of hosts. Once we find them, we check if it's important or not, if it's active or not. If it was inactive, we declare it active. If there hasn't been such a host, we declare a new host. That's okay, we have a new host and it's active. The events problem is thus solved. But how do we declare that hosts have become inactive? Here, timers are useful. We want to check periodically all hosts, whether they are active or not. And we implement a timer. We query all hosts to see whether they are still active, and declare inactive which have become inactive. And everything that's written here on the screen is essentially a business logic code. This is underpinned by very high-performance implementation, and we can create some very cool things with such language. And finally, the last DSL I want to talk about, this is quite widespread, and this is the Suricata rules language. It's used in almost every network sensor. It's very widely used internationally. This is the language in which there's data exchange on attacks. So whenever there's a new attack identified, the rules will be written with very high probability in this language. The language is very straightforward. It contains a number of keywords which describes byte offsets and which help us to identify and detect the attack in the binary traffic. The cool thing is that you can detect an attack in the binary traffic without analyzing for events. Sometimes it just doesn't make sense to do that. The benefit of this is that it is broadly used in various systems. You can work with the traffic right in the flow of it, and there's no need to single out events. Let's move to the next section. This is the process of developing cybersecurity expertise for ICS systems. There are a lot of expert teams in positive technologies.
So let me tell you about the process. So you realize from what I said that expertise looks like this. We take an expert, the expert knows something, then we give him DSL and some time. As a result, we get ready-made expertise. I went to our experts when I prepared this slide, and they said, yes, that is true. Unfortunately, life is a bit more complex. Experts have specialization, and development of expertise is development as such. And development goes through certain steps and cycles, including development, testing, releasing. Same with expertise. So, two last slides are about the process itself. This is a monstrous slide, so let me first show you this simpler one. Who develops cybersecurity expertise for ICS? First, BDM, business development managers, and industry experts. Experts for technological networks need them very much because they know how the system, what the system is built of, the customer system. One thing is power generation, the other thing is oil and gas, metals, the third one. They are all different, and how do we have to build protection for them? They must all be different. And very often the customers do not know what we have to do, actually. Industry experts are badly needed for that. ICS experts, they developed a lot of things before. They realize how the system is working. They know how ICS Siemens works, how Yokogawa works, how the infrastructure works. Reversers and vulnerability researchers. If you get a laboratory stand with a certain system and nobody learned it before, it takes a week, a month, and even more. And experts find more than 10 vulnerabilities. If our experts can do that, so the criminals can do that as well. They can buy the system and find vulnerabilities, backdoors. So we send everything to them to find unknown attacks, zero-day attacks. Protection experts, this is the way we call them. It's the people who know most of, who use the product, who exploit them, live products, and they know what kind of things can be done and what cannot be done, so they help us a lot. DSL experts for the product. You realize that DSL is written for a certain task, but the language is quite complex. It has its own implementation, and we need to optimize it. The DSL experts are the people who know DSL very well, who know what to do with DSL for a certain platform. They know a lot of rules, they can use correct constructs, they can use optimal code. Technical authors. It's not about cybersecurity exactly, it's the people who take part in the development of security expertise. You are not a user. The rule comes to you and you have an incident, and, well, sometimes it's very difficult to understand what the developer of the rules meant. And it's very well if the rule is very well described. So documentation is needed. So technical writers, technical authors write the documentation, good documentation, QA specialists for the product. After the development, of rules, you have to check them. You check their actual operation in the product. You must be sure that they really work and that they do not generate additional workload for the product. So cybersecurity products are complex. They reduce the speed of operation of applications. When the people say, well, they accelerated by 2 times, but they wrote twice as many rules, so we are at the same level. QA specialists prove that you are moving in the right direction. And press service, the pink one. So many people are involved in expertise development, and they have to be rewarded with their payroll and with the news saying that those people achieved such and such success. Press service is needed for that. Now, let us look at it from a different angle. This is the way the process looks like. I'm not going to talk about different blocks. The dark blue, light blue, and the orange are different. Cybersecurity expertise for ICS systems. We have to learn about the system. It should be not just a paper document, it should be a live system, and you have to see how controllers interact, how security and ICS interact. So we have a laboratory stand, a laboratory system. So the task is to get the system. If you don't have the system, you have nothing to examine. So that is light blue. What is next? Then we generate expertise for each product. We have a lot of such products. And for each product, we go through stages described previously. We are talking about standard attack vectors. They are all similar. For example, for any SCADA system of any vendor, the project substitute is a vector of attack. So in the project file, you have all the users, all the security rules. If a criminal replaced that file, he can do anything. It's a standard attack vector. Take SCADA and then see whether the file is substituted or not. Or engineering software. It's launched very rarely. So we saw what kind of engineering software is used here, and we launch it and see what kind of alerts it can generate. That is the dark blue and the light blue one, the red one. Now, so in a month or two, you can find about a dozen vulnerabilities, for sure. That is why the laboratory stand, in parallel with expertise, goes to zero-day vulnerability research. And when we found them, you have to do something about it in the product. But this is wrong. If you know the process of operation with zero-day vulnerability, you have to tell the vendor secretly, and the vendor should eliminate it. When it is eliminated, then and then only you can disclose that information publicly. Then we go back to the blue box and generate expertise. That was my last slide. So 2 last points. If you want to develop your own product for cybersecurity, you need experts in security and excellent developers who can develop engines. They should be friendly. Experts should work with a certain DSL. That's what we are currently doing. Even when we deal with other systems not related to cybersecurity. It's a general approach, a good one. If you have such a hammer like DSL, it doesn't mean that automatically you have expertise. No matter how good experts you are, you need a process to get the final results. And in the process, you have a lot of other roles which I showed you, and you will get the result in the end. Thank you. Have you got any questions, please? Hi. How well do the people take patches and other messages from Russian sources abroad? I'll tell you an interesting story. Some time ago, our colleague found a vulnerability in a Japanese ICS. The Japanese vendor accepted it and wrote the name of the expert there. So yes, vulnerability data is accepted, but they have to deliver patches, and please ask them not to prohibit installation of such patches in the territory of the Russian Federation. Thank you. An alternative to DSL is the normal API for popular languages. Why don't you choose this approach? I see that this is more comfortable for rank and file users. Good question. Of course, you can develop an application with classical C#, publish APIs for experts, REST API, doesn't matter. Yes, briefly, you can do it. But DSL has one advantage. DSL is a text code which can be used without plugins. We have a text expertise, and all consultants accept it. It doesn't affect exe files, executable files. If you add binary modules, well, in C#, if you bring it to regulators, DLL, for instance, it's more dangerous in Python, for example. Python, what kind of libraries did you upload? Is there anything wrong? So a lot of questions. Yeah. We offer an isolated sandbox, an isolated environment, which doesn't affect us. But your approach is feasible. We have such an approach. Instead of writing a new language, they just build a certain structure, and we call it DSL. The DSLs which are not presented here, outsourced DSL, YAVL is written with a tree, with keywords, with special signs related to each word. So there is no one right answer. We have different approaches. Your approach is quite good. Thank you. Excuse me for a very long answer, but you can do it. No problem. Ilya, hi, thanks for the presentation. The question is about DSL, Cognac, Mill. What about open source? Are you going to develop something standard like Suricat so that everyone in the world knows about it? Good question. I'm not going to tell you anything about our languages, but many languages that Positive develops for its products start moving to open source. We have such movements, but I cannot tell you anything specific or anything about our plans. The plan is first to spread it across our own products, and then perhaps start sharing it wider. Including the languages. Thank you. ICS has a very narrow set of customers. Yes. Each OO has scoop, OPS, and video surveillance. Have you any precedents about locally produced, invulnerable things which someone broke and exploited? That, for example, doors were blocked or unblocked. Look, the situation with customer incidents is not commented. Well, please don't comment. Did you meet such facts or incidents? Actually, there are a lot of incidents which we don't know about because the customers never share information about breakthroughs. So, of course, such cases might happen. They are surely happening from time to time, but we don't get such information. You don't have it. We, the developers, didn't see that. So formally, they are invulnerable. Okay. Have you got more questions, please? Yes. Did you have installed NICAF for ICS shift for security? That will like what Cognac DSL language for to phase protocols at a testing level. Cognac is used for specific task of working with protocols. Phasing, we don't remember anything. No, in general, what we do with those DSLs, we write the rules for certain protocols. Our systems looks at the traffic, looks at the protocols, look at the events, and use it in production. That's all I can say. Well, so you talked about manufacturing protocol. What about RX 485? It's transport. We take transport from Ethernet network because the most interesting things happen there. Attacks in ICS take place at the high level. If we go below, down there, of course we can collect data from there as well. But usually we don't do that. Although, if you look at our list, 485 is there. But in practice, customers don't do that. They work at the highest level. Thank you for the presentation. What do we have to do if we found a vulnerability, but there is no patch from the vendor? How can we minimize the risk, or shall we take that risk, or set up multi-layer defense? Vendors often do not publish patches, but recommend certain workarounds. They do it very often. For example, limit access to such services or make such tunings. So it depends on what kind of vulnerability you disclose. It depends. If something is available through the public network, of course, that's rather bad. So try to do something with the service which might be affected with the libraries. Maybe you could switch it off at the operating system level and then wait for the vendor response. More questions, please. Hi, Oleg. Hi, thanks for the presentation. I have a small specification for the slide with the protection. It's about prioritization of the problems. I didn't see the value of the assets, the asset value. Asset value is important. Of course, you can calculate it differently, evaluate it differently. The architecture, the money lost, but this is important. You can write scripts to find assets which are most vulnerable from the network point of view. CCR, for example, in SCADA, which is faced inside the company and outside at the same time. Maybe there is nothing critical there, but for us it's important, very important, critically important, and all the events should be processed in the first place there. Did you think about downloading configs or threat models from the customer to reduce the number of such attacks, to get some adequate rules? Yes, a very good question. When we talk about control of security, we have two metrics here. First is how dangerous is the vulnerability, high, medium, low, and second is how important are the hosts to your company. For example, print server or print server or some central server for the database. So of course I couldn't squeeze everything to this slide. I have limited square here. But actually, that's what we do. We prioritize the level of severity for the incidents, depending on which node did it take place. If it's an important host, it's one thing. It's in a non-important host, it's another thing. In MIL, we don't have such function yet. There is no automation, and we're not planning it there. But in other areas, we're doing it. We have protection control products with box-ready requests, which can evaluate the importance of hosts in your infrastructure. Domain controller, important. Print server, well, not so important, and so forth. So we try to take into account such factors. More questions? Hi, thanks for the presentation. At which stage do you scan? Does it take place when you deploy the system at the customer, you analyze security, or is it a continuous process which takes place from time to time? There are a lot of concepts about that. Let's tell you about a couple of them. The first approach is when you scan the customer from time to time on a regular basis and see what is happening. You have to do it on a regular basis. For example, you install a patch and you must know how it works. Another approach, I forgot the name, like continuous scanning on something. It's an unbreakable scanning in real time, once a minute. But for classical scanners, it's a difficult task to achieve because it loads the system. It's a lot of workload. Another approach is near real-time scanning. If the scanning system connects to CM, and we passively collect logs right now. For example, CM looks at the processes launched or not launched, and depending on which processes were launched, it tells us what kind of resources are active on your host. So there are different approaches. Another question, please. Hi. Thanks for the presentation. I missed the beginning. You told us about several DSLs and about sending data from expert to your system. What do the experts send to DSL? Python, non-Python? Well, how easy it is to write the stories for your internal employees. So, are you an expert yourself? Well, but this is the right question. As soon as you have your own DSL, the question is how to make it convenient to populate it. The more DSLs you have, the more tools you need. Tools for testing, First of all, then sometimes integration with some ES things. We had presentations about plugins for the correlator, and there is Misha Maximov behind you. He wrote his own ETE, which is used for many companies right now by many people. Of course, we are focused on providing experts with the widest range of instruments to use. And the second point is that our tools, development of tools is not the target in itself. It's auxiliary. So we have to use only the most important and most needed tools. But as soon as you have your own DSL, you need development tools. EDEs help you to write plugins. Even an expert can easily integrate with such systems. Thank you for your questions. No more questions? Colleagues, I cannot do that. One. I have to choose one. You have two packages. One is to me. Oh, sorry. I am paid by my company. Well, all right. Let us choose the UDE question, because I am going to go from here and experts will surround me and say, where are UDEs for myself?